We ended the previous recording by showing you how this new record was classified using the k-nearest neighbors algorithm. In particular, we chose the value of 3, which means we consider the 3 nearest neighbors of this new record, and its classification was decided by majority voting, since there are 2 Virginica and 1 versicolor, so the majority is the Virginica type, and so this new record is classified as Virginica. Now, the question now is actually whether this classification is correct. We have no way of knowing since this is a new record. Okay, and also, how good is the k-nearest neighbors algorithm in general in classifying data? So, in this video, we are about to answer this question. So, in order to know how good is the k-nearest neighbors algorithm in the classification, we ask the question of how well does the k-nearest neighbors algorithm perform on existing data. So the strategy here is actually to divide our existing data set, which we have seen in the previous video, into 2 sets. The first set is called the test set. Okay, so my first 8 records here will be my test set. We want to know if the k-nearest neighbors will predict the classifications in the test set here correctly. Okay, and the rest of the data will be called the training set. The training set is the source of neighbors in which the classification will be performed. Okay, so to illustrate this idea, let's go to the next slide. In this graph, we have plotted the training set in this graph, we have plotted the training set using the solid squares and the solid circles. The solid circles represent the versicolor flower, and the solid squares represent the Virginica flower. Furthermore, we have plotted the data in the test set using hollow squares for Virginica flower and the hollow circles for the versicolor flower. As you recall, we have assigned only 8 records in the test set, so we see that there are 8 records plotted in this graph here. 8, 7, 6, 5, 4, 1, 2, 3. Okay, so 4 of them in the test set have the actual classification of versicolor, and 4 of them have the actual classification of Virginica in the test set. So let's write them down. So records 1 to 4 have the actual classification of versicolor. Let's change. Okay, let's keep this color. Okay, so records 1 to 4 corresponding to here, 1, 2, 4, and 3 are of the actual versicolor flower. And records 5 to 8 are of the Virginica flower. So okay, so what happens is that we are able to use the k-nearest neighbors to actually predict what these classifications will be. Okay, so at this stage, we ignore the actual classifications and we just ask ourselves, what would the k-nearest neighbors algorithm tell us about these classifications? So let us use the same value of k. Let us use k equals to 3, which means that we want to have the 3 nearest neighbors of each record in the test set. Okay, so let us go to the first record in the test set, which is number 1, and of course the 3 nearest neighbors are these records, and they all belong to the versicolor category. So the predicted classification for record number 1 is also versicolor. Okay, so let's go on. So let's erase these circles in order to ensure that the graph is not so cluttered. Okay, so let's go on to record number 2, which is over here. So record number 2, the 3 nearest neighbors this record, and this record. So we see that among these 3 records, there are 2 versicolor and 1 virginica. So by majority voting, versicolor is in the majority, so the predicted classification for this record will be versicolor. Okay, so let's erase this off and let's move on to the third record. Okay, the third record is found to be here, and its 3 nearest neighbors, this record, and this record. Now, among the three nearest neighbors, there are 2 virginicas and 1 versicolor. So in this case, the virginica is in the majority. And so for record number 3, it is predicted to be virginica. Okay, let's rub it off. And let's look at record number 4. As you can see, record number 4 is over here. And its 3 nearest neighbors are all versicolor. So okay, so we have settled ourselves with the first 4 records. Let's move on to the next 4. Okay, so record number 5 over here is its 3 nearest neighbors. These 3 records. Let's see. This one is probably nearer. So in the majority is among the 3 nearest neighbors, 2 are virginica and 1 is versicolor. So virginica is in the majority. So record number 5 is predicted to be the virginica flower type. Let's move on to record number 6, which is here. Right, record number 6. Let's move the mouse pointer here. And we notice that it is in a vicinity of its 3 nearest neighbors are all versicolor type. Okay, so these are its 3 nearest neighbors. I've judged them based on just by looking at it. So, and it's all the 3 nearest neighbors are all versicolor type. So its classification will be versicolor. Okay, let's move on to number 7. Right, record number 7, which is found here. Okay, let's look at its 3 nearest neighbors, and they are probably this one, and where is the nearest neighbor? Third nearest neighbor. It's probably okay, this one. So its 3 nearest neighbors are all virginica type, and so it will be classified as virginica. And let's look at record number 8. Okay, which is over here. Right, so its 3 nearest neighbors are probably this record. By distance, probably this one is nearer and this one. So its 3 nearest neighbors are all virginica. Okay, so now we have the predictions made by the k nearest neighbors on the 8 records in the test set. In doing so, we have actually ignored their actual classifications, which are in this column. Now we are ready to summarize how good the prediction has been. In other words, we will ask ourselves, has the k nearest neighbors been able to predict all the actual classifications correctly? If not, which of the classifications and how many of them did it get wrong? Okay, so how you can actually summarize the results of such a classification is in the confusion matrix. Okay, it is actually in a matrix, and let's set up the matrix. So it's predicted versicolor, predicted virginica, then actual versicolor, and actual virginica. Okay, so so this is what a confusion matrix will look like. It compares the number of predictions versus the actual classifications. Okay, so in the first cell here, we are summarizing how many of the versicolor type have been predicted correctly, because the predicted versicolor and the actual versicolor is the same. So we can see that this is true for records 1, 2, and 4. So we actually have 3. Okay. Okay, next. In this cell, we are summarizing how many records have actual classification of versicolor but have been predicted to be virginica. So in this case, let's rub off the ticks here. And in this case, we find that only record 3 meets the description, and so we have only one record that is actual versicolor but predicted to be virginica. Next, in this cell, we are summarizing how many records have of type virginica have been predicted correctly to be predicted as virginica as well. So erasing this tick, let's see that we actually have records 5, 7, and 8 to have been predicted correctly. So again, we will fill in this cell here. And lastly, let's rub off these ticks. This last cell summarizes how many records have actual classification of virginica but have been predicted to be versicolor. So we see that actually in the data here, we have actually one record which fits this description. Its actual classification is virginica, but it's predicted to be versicolor. So we enter 1 here, because there's only one record. And there you go. The confusion matrix here over here summarizes the outcome of the predictions on the test set as compared to the actual classifications of those records. Okay, so this is the end of a video. With this, you are ready to attempt the pre-class activity in the problem set.